Hi everyone, we're going to work through an application involving lob sines, lob cosines. And this is actually one we're revisiting. We looked at this when we only had right triangle trig and we were able to do it, but it makes sort of a messy substitution problem. So I just want to look back at it now that we have lob sines, lob cosines. Okay, so we have a balloon and there's two different people that spot the balloon, and we know that the angle of elevation for the first person to look up at the balloon is 18 degrees, and for the second person it's 12 degrees. And then the only other piece of information we're given is that the two observers are 80.4 meters apart, and I'm actually going to give you a tiny bit more. They are on a straight line, so if you draw a straight line from the further person to the balloon, the closer person's on that same line, so we're not getting anything too weird. We can look at this as kind of 2D. And for part A, we want them to be on the same side of the balloon. So basically we have this going on. We're interested in figuring out how high the balloon is, so that's our goal. Okay, so person A is the closer person. They have an 18-degree angle of elevation, and person B has a 12-degree angle of elevation. And then this is what we know. We know this side length right here. So let's see, what do we have? We can try to focus in on this little triangle. This is what's new. Before we had to use the right triangle, but now we can actually look at this one and see if we've got enough info. It doesn't look great at first because I've got one side and one angle, but actually I really have enough info to get this angle as well. I can take 180 minus 18, so this is a 162-degree angle. And then I can even get this one once I've got the other two. So this is 162, 174, which means this little top one is only 6 degrees if they're going to add up to 180. So I have all three angles and I have one side. I could use a law of sines to get either of the other two sides. So let's say I want to go for this one. I'll call it x. I would say sine of 6 degrees over 80.4 is equal to, which one am I going for? This one, sine of 12 degrees over x, which would mean that x is going to equal 80.4 multiplied by sine 12 degrees and divided by sine 6 degrees. Okay, so 80.4 sine 12 degrees divided by sine 6 degrees is about 159.92. And that is this length right here. Okay, so that's not quite what I was looking for. I was looking for h, right? But that's actually really helpful because now I can look at the right triangle and I know the hypotenuse. So at this point I can say I want to relate opposite to hypotenuse. I'm going to use plain old sine. No need for a law of cosine or a law of sines. If I catch you finding law of sines, law of cosines on a known right triangle, I will dock you a little bit. I want you to keep using your basic trig function definitions. So sine of 18 degrees is equal to h over x. And I just found out that x is 159.92 meters, which means h is that number, 159.92 times the sine of 18 degrees. 159.92 sine of 18, which is about 49.42 meters. Okay, so there's the height of the balloon for part A. For part B, we're just going to change up the picture a little bit. We're going to say person at point A, person at point B, and the balloon are still all in a straight line, but now A and B are on opposite sides of the balloon. So for that picture, let's see, I would say we have our 12 degrees and our 18 degrees, and again, not really to scale. That's a little big looking for 12 and 18 degrees. And here's our balloon, and we want to figure out the height of the balloon. And what we know is that this side length is 80.4 meters. Okay, so once again, what we did before was split this up into the two right triangles that share side length h, but now we're going to pay attention to the entire thing. And what we've got is two angles and a side, which actually means we really got all three angles because we can subtract from 180. So if I have 12 degrees and 18 degrees, that adds up to 30, which means this has to be 150 degrees. So I can use this again to solve for either of these other two sides of the big triangle. That's not what I'm looking for, but once I've got a single side of one of the right triangles, I can use right triangle trig to solve for h. So let's just go for, here we'll call this, use a different letter, y. I would say that sine of 150 degrees over 80.4 is equal to sine of 18 degrees divided by y, which means y is equal to 80.4 sine 18 degrees divided by sine of 150 degrees. And if I check that out, sine 18 or sine 150, I get about 496.899, so 0.90 meters. And that's distance y. Okay, so again, not what I was going for. So I do still have to work through two triangles, but I don't have to do the whole 2x2 system thing. Now that I've got that side, I can use what it looks like a sine once again and say sine of 12 degrees is equal to h over the value I just found, 496.9. And then h would have to equal 496.9 sine 12 degrees. So we just need to take what we just found and multiply it by the sine of 12, and we get 103.31 meters. The balloon is about 103.31 meters high. All right, thanks for watching.